All right, number 14. We have KLM is a triangle, so I should probably draw the triangle. It's KLM. It says that K is congruent to L, so I'd put my two little congruent symbols on there. Then it says that KL is 9x minus 40, so we'll put our 9x minus 40 along that side. LM is 7x minus 37. It's minus 37. And finally, we have KM is 3x plus 23. Now, we don't have the luxury of these being angles. These are side lengths. Side lengths don't equal 180. It's the angles that equal 180. So we can't do something like these three equal 180. That wouldn't make sense because those are our sides, not angles. So there must be some that are congruent. Well, if it said this was an equilateral triangle, all of these would be congruent. We could pick any combination we want to. But it doesn't say it's an equilateral triangle. It says that K is congruent to L. So you have to remind yourself that if I have two angles congruent on a triangle, it means those sides opposite are also congruent. Giving me the setup that 7x minus 37 equals 3x plus 23. Then we'd solve for x and plug it in to get all of our different sides. Mm-hmm.
So how did you get 7x minus 37?
Because we learned a rule in the last class that if the angles are congruent, then the sides opposite them are congruent. So I said the two sides were congruent.
Oh.
Anytime you have two congruent angles, it means you have two congruent sides as well. Anytime you have two congruent sides, you have two congruent angles. I think that's as far as I'm going to go on that, Logan. Is that fine? Yeah. All right. Other questions? Number 8. We have an equilateral triangle. Equilateral triangles are all 60-degree angles. So for number 8, I would just simply go, oh, that must mean a 4x plus 8 equals 60 degrees. And just solve it. Yep. Last second questions. 13. Did you start 13?
No, but I can come. Oh.
We're not just going through questions.
Yeah, I know. You don't have to solve it.
I'll very quickly set it up. So
explain like how to solve one that
triangle QRS. What was that?
And sometimes I don't want you to solve it. It's just like.
Well, I'll just go through it really quick.
Like, how do I find one for the angles, not the sides?
Not the sides. Well, that one isn't. Okay. So this one says QR is congruent to RS. And then they start listing some angles. They tell us that Q is 8x minus 17. They give me R is 19x plus 4. And they also give me angle S. Angle S is going to be 5x plus 1. And so those are definitely all angles, right? So, oops, sorry. So if I wanted to, I could go this plus this equals 180 because they are all angles. That's what we've done in the previous lesson. But we might shortcut this one in realizing that, hey, if I have two congruent sides, it also means I have two congruent angles. So I can actually shortcut this problem. Rather than doing this plus this equals 180, I could simply go 5x plus 1 equals 8x minus 17. And solving that's going to be easier than solving one that goes 19x plus 4 plus 5x plus 1 plus 8x minus 17 equals 180 because that's a longer problem. This is kind of a shortcut. It's kind of the same thing as this one. This one went from angles to sides. So I gave you two congruent angles, which means I gave you two congruent sides. This one gave you two congruent sides, which gave you two congruent angles. That is just the isosceles triangle theorem in converse in action. All right, anything else? Yeah.
Can you go over how to set up number 10? Like, this is
Yeah. Oh, what's number 10 say? 10 has this one. So 10 is basically, in essence, so I gave you this angle here, right? I'm actually asking to solve this triangle. So I'm going to forget about this for a second. I'm just going to find this angle. To find this angle, you need to realize that we have two congruent sides, which means I have two congruent angles. So once again, two congruent sides means I have angles that are congruent opposite each other, which means this one must be 29 degrees. Now, anytime you have two angles of a triangle, you have the third one. So to get this angle here, I'm simply going to go, okay, that's 180 minus 29 minus 29. That's going to be, what, 122?
Yes.
122 degrees. And now what I'm going to say is, see how these are pointing to the same angle? They're occupying the same space, so they must be equal to each other. So I'm simply going to go, okay, that must mean 11x minus 65 equals 122, and then I'll just solve for x for that one. Is that good on that one? Okay. Any other quick questions? Okay. I do have a lot to get through, and we have a quiz, so I'm going to give us as much time for the quiz as possible. So we're going to jump to what could be easy on your test. If you pay attention to this, this will be an easy section on the test, because a lot of it just has to do with, do you understand, next week. Our test will be next Friday. Next Friday is our test. Okay, we have a quiz today. Next Friday is our test. All right, congruent triangles. In essence, congruent triangles should be easy. All congruent triangles they're the same. Let's go ahead and put this here. They're the same shape and size. And in fact, they're the same triangle. If I copy and paste the triangle and I have two triangles, those are two congruent triangles. They are, in essence, the same triangle. They just might have different letters on it. To be the same shape and size, all of our corresponding parts, and I'll talk about corresponding parts in a second, but all of our corresponding parts must be congruent or the same. That means all of your angles and sides must match up between the two triangles. They have to, because they're the same triangle. So if we look at our shape down here, we have two congruent triangles. If you look at angle A, it must match up with a corresponding part on the other triangle. And if you look here, it matches up with D. They're the same size. That's what those two arcs mean. C matches up with F. B matches up with E. The length AB matches up with ED. FE matches up with BC. And our final triple marks, AC equals FD. They are, in fact, two triangles that are the exact same. They just have different names and are in different locations. They just copied and pasted it. All the angles are the same and all the sides are the same. Now, when you say two triangles are congruent, you write it as a congruent statement. You say triangle ABC is congruent to triangle DEF. You can name your first triangle however you want. You just have to pick three of the letters any order you want to. Your second one is dependent on how you name the first one. Your corresponding parts must match up. What angle is equal to A? Let's try again. What angle is equal to A? D is, not F. D is, because they both have the similar marks. So A and D are equal to each other. So notice how A and D both lead the charge? B is my next letter. What other letter matches up with B?
E.
E. That's why my next one's E. What matches up with C? F. So those orders matter. So it has to have a corresponding. So let's mix this up a bit. Let's have a little word jumble. Let's say I didn't name it ABC. Let's say I named it CAB. Since I jumbled up that triangle, I have to jumble up the other one in the appropriate way.
So FD.
F. And A goes with D, so we'll have D. And finally, B goes with E, so it'd be FD. E. Now, not only when you write it do your angles match up, your sides also match up. So, look at side AB. That should match up with DE in order. BC has 2 tick marks. EF, 2 tick marks. And finally, first and last letter, AC, matches up with first and last letter, DF. So the order matters in which they're given to you. Very important that those match up. Before we talk a little bit more about that, we're going to talk about something called Kapukatika, CPCTC.
Are you serious? No, like, seriously. That's the name of it?
That's my name for it. Most people just call it CPCTC.
Doesn't stand for anything?
It does. Yeah, you don't have to memorize Kapukatika. Most classes would. If we were doing this longer, we'd all be saying Kapukatika. It's just fun to say. Try it. Kapukatika. But most people just call it CPCTC. Yes, it absolutely stands for something. All Kapukatika stands for is if we're doing proofs. We're not doing proofs in this section. We'll do proofs next semester on this, possibly. But if we're doing proofs on this, we would be using Kapukatika. And all that says, and it's fancy words for a super easy concept. Let's go ahead and write it down real quick, and then I'll call on you, okay? It stands for corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. All that says is if you know 2 triangles are congruent, all the parts are congruent. I can then say the angles are congruent and the sides are congruent. We kind of just hand waved and said it works. This would be if I had to write a proof, I would use Kapukatika to say, yeah, everything's equal because corresponding parts of congruent triangles are in fact congruent. Now, what Kapukatika does for us is if I tell you JKL is congruent to PQR, you can list all of the angles that need to be congruent, and you can list all of the sides that need to be congruent. And you actually know what ones need to be congruent. J's our first letter, right? What's our first letter of our other triangle? P. So that's going to mean that angle J is congruent to angle P. Second letter is K. What's our second letter in another triangle? Q. So that means K is congruent to Q. And finally, we're left with our last letter, and that's L. Needs to be congruent to R. Then when we're listing our sides, we're going to list them in order. So my first 2 letters are JK. So the first side I'm going to talk about is the side JK, because that's a triangle, right? Every triangle has a segment, 3 segments. So my first segment I'm talking about is JK. That matches up with PQ. Kapukatika. Yeah, you got it. All right. Then we'll do our next 2, which would be KL. What segment would KL be congruent to? QR. It's a nice QR code. And here's what I do. I typically take the first and last in that order. I call it JL. But you could call it LJ if you wanted to. I just do the first and last, JL. What would JL be congruent to? PR is correct. Now, be careful what I'm asking next. It says write another valid congruency statement. We've already listed all of the angles and all the sides, right? When I ask for another congruency statement, I'm saying take this and jumble it up. So I gave you triangle JKL. You need to write that in a different way. So instead of JKL, maybe I do LKJ. So I just have to pick another way to write this. realizing that if I jumble up the first one, the second one has to be jumbled up the same way. Well, it looks like I just flipped the L and J, right? So I'll just flip the P and R for the second one. So L matches up with R, so we go R. K matches up with Q, so we're going to put a Q. And what do we have? J. J matches up with P, so it's RQP. Requipa. Do number 2. If you haven't already, do number 2. I'm telling you right now, this is a test question.
On the quiz.
Not on the angles. It look like everyone got angles. We got a little tripped up on sides for some people. So our angles would be angle W is congruent to angle E. We're going to have angle X is congruent to angle F. And finally, angle Y is congruent to angle G. Now we know all the angles are congruent, but as a reminder, all of our sides must match up as well with those tick marks. So to do the sides, you just do them in order. WX is going to be my first side. So we're going to have WX, first 2 letters, is congruent to the first 2 letters of the next one. The next one is EF. If we take the next 2 letters, the segment XY,
FG.
XY is going to be the same as FG, correct. And finally, me personally, I take the first and last, but you could call that YW if you wanted to. I'm going to call it WY, is going to be the same as EG. Can someone do me a favor and throw out, we were supposed to jumble up WXY. What did you put down?
YXW.
You put YXW. If you put YXW, you should have put it as GFE. Because your Y still matches up with G, your X still matches up with F, and finally your W needs to match up with your E. Any questions on those? If you can't do that, you're missing out on one of the easier questions that's on the test. One that should just be copy paste, yeah. Kind of free points, right? If you know what you're doing, this should be as easy as free points because you're just copying orders of things. Okay, this where it gets a little more complicated because I can also go ask you, well, on this drawing, mark up what's congruent. So I'm asking you to mark it and then explain it. So marking it is, yeah.
Marking just having the column length of each angle be congruent to each other. So just add 1, 2, 3 marks.
Absolutely. And then for sides, we do the same thing. 1, 2, or 3 marks, right? Mm-hmm. So if I'm marking angles, we have K needs to match up with A. So we'd put 1 mark on K and A. Then we have P and Y need to be congruent, so I'll put 2 arcs on P, 2 marks on Y. And finally, M and C, I'll put 3 on M and 3 on C. But once again, we're not just marking up angles, we're marking up sides as well. But the order in which those are written tells you what to put the marks on. So if you look at the first 2 letters of the first triangle, it says K to P. So from K to P, I'm going to put 1 tick mark. And then for the other triangle, it goes A to Y is my first one, so I'm going to put 1 tick mark on A to Y. Then P to M are my next 2 letters, so I'll put a double tick mark on PM. And our last 2 letters for the other one are YC, so from Y to C, we'll put 2 tick marks. Now, I'm out of sides, so let's put a triple tick mark on those 2. That should be KM and AC, our first and last, first and last. Now, if I'd put this on the test, you have 2 options to how to answer this. 1, you could look at the pictures, or you could just look up here. I like looking up here sometimes at the letters, because if it says K to M, first letter, last letter, right? First letter, last letter should be AC. Then you find CY. Well, CY is my last letter and second letter. Last letter, second letter would be MP for the other triangle. PK, that second letter, first letter, is going to be YA for this one. Perfect.
trivia?
Yeah.
How did you know it's like flip 3 lines and like 2 with 3 lines and
You could pick whatever number you want.
like
Y, well, angle Y, second letter. Second letter is P. K is our first letter from our other triangle, so our first letter from the other triangle is A. Here's where I could throw it for a loop, though. ACY is still an angle. It's an angle where the vertex is C. So if I color in ACY, this can be a review for the semester exam too. ACY will be this angle right here. Remember, to name an angle, you can name 3 points or you can name 1 point. If I use 3 points, the center one is our vertex. So that means I'm matching it up with M.
is it K and P?
But we're going to use the 3 letters, so we'll use K, M, P. Or you could have did PMK. Angle K, M, P. Now we'll notice the next ones are triangles. Triangles, everything must match up. Angles are different than triangles. An angle is what's in red. What's in black is the whole triangle. So if I say MPK, you have to make sure every vertex matches. So M will go with C. P goes with Y. And finally, K goes with A. So it's Sia. Triangle Yak. Y matches up with P, because it is our second letter of each one. Our A is our first letter is K.
PKM.
And then it'll be PKM is correct. All right, so real quick. Notice these symbols, congruent symbols. Congruent symbols say I'm naming 2 segments. That's what a congruent symbol says. It says name the 2 segments that are the same size. Compare that to here. I no longer have the segment symbol and I changed it to an equal sign. That means if I'm asking for BN, I'm looking for the distance, because nothing's written above it, which means distance. And distance equals a number. So I'm looking for numbers for all of these, especially where it says measure. I'm looking for numbers. So that means I need to come back to this drawing and figure out how all these numbers translate to these. Let's do the sides first. So for sides, we should realize that ST, let's put 1 tick mark on ST. What side does ST congruent to? FB or BF. So this would be 17 centimeters. BF would be 17 centimeters, so I can come here and put 17 centimeters. The next 2 letters in order are TW. So on TW, I'll put a double tick mark. What segment is TW congruent to? What was that? BN? I think TW, we had the N correct, but I think it's FN. Because it's second last. Maybe you heard my SW. I think that's what you heard, yeah. So we have TW, FN. FN. So we'll have a double tick mark. So anything with a double tick mark must be 14 centimeters. So our TW must be 14 centimeters. Our last one is SW. SW, I'll put a triple tick mark. Bailey, SW is congruent to what line? BN. So we'll have our BN. In Spanish, that means good, right? All right, so we have a triple tick mark. So anything with triple tick marks has a 9 on it. That's 9 centimeters. So our BN is going to be 9 centimeters. We'll find out. So I'm going to go S. Angle S is congruent to B. S is congruent to B. So that means B is 67 degrees. Let's find angle B over here and write 67 degrees there. T, well, T is congruent to F. So I'll put a double on T and a double on F. Do I have T or F labeled with a number on it? But I need to find F. How many angles do I know of both of these triangles? If I know 2 angles, how many angles do I know of a triangle? I know all 3 of them. If you know 2 angles of a triangle, you know all 3 of them. If I know I have angles 82 and 67, how do I find angle F? Yep, go on. Yep, so we're just going to go to find F. I'm going to do 180 minus 82 minus the 67 degrees. Can someone help me out with that? 149. That seems off.
Well, I'm sorry, 149 minus
31. I heard 31 from 2 people, so that's 31 degrees. So that makes F 31 degrees. If I asked you for T, you'd say T is also 31 degrees. And that must mean W is our last letter is equal to N. I think, Lacey, you mentioned that a while ago, right? Yeah. That W is going to be 82 degrees. So we'll have 82 degrees right there for W. Take a quick second and try number 5, realizing that number 5 is a different type of problem. It's the same but different because there's an isosceles triangle in there. We might have to solve our isosceles triangle angles in a slightly different way. So let's give that one a shot. I mean, I don't know why half of us didn't even start it. But if I have 2 tick marks, we know that GH is congruent to XY. GH already has a tick mark on it, so for XY, I'm going to put a tick mark on it as well, because those are congruent. We also know that HJ is congruent to YZ, so I'm going to put a tick mark on that, which means our 2 bases are congruent as well. You're done with your sides. They're all either 27 or they're 18. So for my side lengths, that's going to be real easy. GJ is 18, XY is 27, and our ZY is 27 as well. That shouldn't have been the hard part, because that's just you putting tick marks on stuff that is congruent. The hard part is our angles, because we're going to find out that Y is congruent to H. Well, that one should be easy enough. Put a tick mark on Y, put it on H, so H must be 38 degrees. What I want us to focus on is, if I have an isosceles triangle, what do we know about the base angles? They're the same size. So as soon as I have isosceles triangles, our base angles are congruent. So Z and X must be congruent to each other. Base angles are congruent to each other because the sides are congruent. That means to find that angle, we should know how to, if you know one angle of an isosceles triangle, you know all 3 of them. What happens when I add up all the angles of a triangle?
180.
They add up to 180, and I already have 38 taken care of, right? Mm-hmm. So for that triangle, I have 180 minus 38, which is going to equal 142 degrees. Does that mean each of these angles is 142 degrees? No, that wouldn't make sense, because it'd be 142 plus 142. That wouldn't make sense. 142 must be split between these 2.
So you divide it by 2 and that's how you get it?
Yep, because they have to be the same size. So normally we wouldn't know how to find it, because one could be 40 and one could be 102. But because they're equal, we're going to take that 142 divide it by 2, which will equal 71 degrees, and that's going to give you both of those angles. And since both z and x match up with g and j will also be, bless you, 71 degrees. So the rest are 71 degrees. But you had to know that an isosceles triangle we can always find if we know one of them, we know all of them. Regular triangle, if you know 2, you know 3. For an isosceles triangle, if you know 1, you know all 3 as well. Okay, we're not gonna go through all of these. We're just gonna do a couple, and mostly we're just gonna set them up, because once we set them up, you can solve it for x on your own. So, for example, this one. We have to write equations to solve for these missing variables, which means I need to know which sides are congruent. So we go back up to the naming, UV. UV I put 1 tick mark on. What else do I put 1 tick mark on if I put one on UV? Not RS. I put it on UV. That's it's going to be ST or TS, correct? Because I used the first and second for UV. Now we move on to VW. VW matches up with what other 2 letters? VW matches up with which other 2? RS or SR. So we'll put a double on there. And then finally we have UW. UW will match up first and last. That will be TR. Now, we know tick marks work just like equal signs, but you got to match up your tick marks. 1 tick mark matches up with 1 tick mark. That means 12x minus 7 is going to equal the 53. 2 tick marks, 57, matches up with the 5y minus 33. So we'll have a 5y minus 33 equal, I forgot to put the 57, equals 57. And our very last one has 3 tick marks. That's the 3z plus 14 would equal that 50. 3z plus 14 equals 50. I'm not going to solve those. You guys can solve those. We don't have to do that right now. The important part is their setup, because I do want to go on to, which other ones did I want to do real quick before we take the quiz? Oh, I think we'll just keep going down. We'll do 7 and 8. 7 actually throws a little twist in it. We're dealing with angles, so we'll talk about the angles. P and C match up. So I'll put 1 tick mark on P and C. So that's going to be an easy enough one to set up. That means 4z minus 32 equals 36 degrees. What angle matches up with H? N. So we'll put a double on H, a double on N. Well, that's easy enough. That's 6x minus 29 equals 115. 6x minus 29 equals that 115. And our final one must be S and F. F is the tricky one. Austin. Do you have a question, or you know what we were supposed to do?
I found the measure.
Okay, how'd you find the measure?
The measure?
Yeah.
I found the values of x.
Oh, you found the values of x?
Yeah.
Which works. So we could solve for x and plug it in. I'm going to show you a slightly easier way.
Okay.
Okay? We know that this 36 matches up with C, right?
Yeah.
So we can go ahead and say C equals that 36 degrees, right?
Yeah. So
And if I know 2 angles of a triangle, I know all 3 angles. So I can now go, okay, to find this angle, I'm just going to do 180 minus 115 minus 36. And can someone help me out with that? 180 minus 115 minus 36.
How did you get 180 minus 159?
Just a second. I just want to get this. 29 degrees. So this angle is 29 degrees, which gives me my final equation is 3y minus 1 equals 29. Lacey, you asked how did I even come up with that formula? Well, I said that this is 36 degrees, right? Which makes this 36 degrees, which means I know 2 angles of a triangle.
Oh.
So I'm going to subtract those from 180, and I have that missing third angle. Anytime we know 2 angles of a triangle, we subtract it from 180, and we have that last angle. Does that make more sense?
Yes.
Okay. All right. Like I said, the setup's the most important part. That's worth most of your points. If this was a problem, you'd have most of your points if you didn't even solve for it. Solving for it is like that cherry on top. Okay. I do want to get to the last one because I want to describe how you should draw your own triangles. So if you're going to draw your own triangles, this is how I would do it. We have DEF. That's not a good triangle. Let's go here. We have DEF is congruent to JKL. I'm going to draw pretty much the same triangle. Now, when I name them, I'm going to name them in the exact same order both ways. So the first one I'm going to do D first. I'll put E on top, and I'll put F on bottom. Now, if you're smart about this, first, second, third, I'm going to do the exact same thing for JKL. I'm going to put J on the bottom left. My middle one will go on top, and my other one will go there. Now everything matches up exactly. Your left-hand one, DE, matches up with that one. EF matches up with KJ. And finally, your bottom one matches up with your bottom one. Angles all match up much easier. So if drawn correctly, you never have to look back up at how it's named because you've already put everything in the proper order. Now we write the stuff down. We got DE is 18. Yeah.
On F, you forgot the 3 lines.
Oh, thank you. 1, 2, 3. I did. Got him. All right. EF is going to be 23. DF looks like it's 9x minus 23. Our JL is 7x minus 11. JK is 3y minus 21. If drawn correctly and you look at it correctly, you're going to realize that 23 doesn't help you at all. You're going to look at your 1 tick mark and go, yeah.
So would 3y minus 21
3y minus 21 would
equal 18?
equal 18 because they're in the same location. They both have that 1 tick mark. I'm going to quickly solve this one. We got a little bit of time. Remember, to solve these, we would add 21 to both sides. We would now have 3y. 21's cancel out. Equals 39. When you're down to 3y, that 3 is attached to the y by multiplication, so I'll divide both sides by 3. In fact, maybe we'll just put the 3 over 3 so you can see it turns into 1. Divide that by 3, and you should come up with y equals 13. What other equation can I write?
You could write
9x
9x minus 23 equals 7x minus 11.
Perfect. So we can look at both of these are touching the double tick marks. So these two must be equal to each other. So we're going to go ahead and write 9x minus 23 equals that 7x minus 11. For this one, I might draw my line on. I'm going to move the 7x, which means I'm going to subtract 7x because I need all the x's on one side. 9x minus 7x is going to give me 2x minus 23 equals 11. Now I need to get rid of that 23, so I'm going to add 23 to both sides. The 23s are going to cancel out. I'm going to now have 2x equals 34. divide both sides by 2, and you're going to have x equals 17. And we're just going to skip number 9 completely. Yeah. Did I make a mistake?
The 11
Yeah.
turns positive?
Nope. I did have a mistake. Let's go back in time. Boop, 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 boop. Mine's much easier to do than yours. Yeah, I accidentally changed that to a positive. Yeah, something seemed wrong. So I should add a negative 11.
So would it be 6?
Yeah, well, we'll see. So I would add 23 to both sides. That is now going to be 2x equals 12. Now when I divide by 2, yes, I'll get x equals 6. Good catch.